Okay, welcome to Math Ketchup. We're going to be evaluating algebraic expressions in this video. These examples are from our workbook, Algebra Foundations, which you can find on Amazon. Okay, let's get started. Okay, to evaluate algebraic expressions, we really just need to be familiar with our order of operations. Now, we might have learned different acronyms to remember this. I've got a few of them highlighted at the bottom here. We'll look at BEDMAS, but whichever acronym you use, feel free to work with that. If we're looking at BEDMAS, that stands for brackets, exponents, division, multiplication, addition, and subtraction. This is the order of operations. So when we are evaluating, we just need to follow our operations based on that sequence. So to evaluate, all we're doing is plugging in the numbers from the question into our expression. Now it's important we do this systematically. We follow the same method every time just to eliminate any mistakes. So the method we're going to use is we are going to rewrite our expression, and then we are just going to substitute the values into the expression. So I'm just going to rewrite my expression. Wherever there was a variable, I'm going to put open brackets, and then I'm going to fill in the value. So the brackets I have here are in the place of a, so I'm going to put in -2, as that is what the value of a in the question was. I'm going to continue. I now have b. I'm going to put brackets, and b from our question was 3. And in the denominator, we just have a c, so I am going to put open brackets and then fill in my value from c, which was 1. So we are going to go down our order of operations and perform the operation in the proper order. Our first operation is to work inside the brackets. If we go over to our expression, we look at our brackets, there's no operations inside the brackets, so we can skip that for now. We'll talk about that in a minute. Exponents is our next order of operation, and since we only have invisible exponents, we know that those are all values of 1, and we don't need to work with those. Next is division. Now here's where we're going to take a step back. In our expression, we have a fraction bar, which means to divide. But above the fraction bar, we actually have 2 terms. And because they are all above the fraction bar, that means we have to do that first. So what we actually have here is an invisible set of brackets, meaning that we need to perform the operation above the fraction bar. So we actually do have a brackets operation. So let's work out the numerator. 3 times -2 is -6 minus 3. It's all over 1, so we're dividing by 1, so we actually can skip that step because dividing by 1 doesn't change anything. So we've done the division, we've done our multiplication inside of our brackets. That was our 3 times -2. And now we're on to the addition and subtraction. -6 minus 3 gives us a value of -9. And we have now evaluated our expression to get our final answer. Okay, let's look at another example. We have a squared plus b squared. We are going to do the same thing. I'm going to rewrite the expression, but instead of putting the variables, I'm going to put brackets. So this is where the a would be, and we have a square on it. So I'm going to go back to the question and look at the values for each variable that we need to plug in. So this is a, so we are going to put in our value for a, which was -2. Then we are going to add our next variable, so I'm going to put brackets. Go back to my question and see that b has a value of 3, so I'm putting 3 in. All right. We've plugged in our values into our expression, and now we are going to look at our order of operations. So the first thing we are going to look at is brackets. We have no operations inside of our brackets. There's no fraction bar, so we don't have those invisible brackets that we talked about earlier. Next is exponents. Here we do have exponents we need to work with. So we are going to write the expression with those exponents worked out. Negative 2 squared is a positive 2, plus 3 squared, which is 9. So we've done our exponents. There's no division to do. There is no multiplication to do. We are now down to the addition, and that gives us 2 plus 9, which is 11. We're down to our final value, so we don't need to worry about subtraction, and we have our final answer. All right, for level 2, we are going to continue with the same method. We are going to insert our values into our variables, and then we are going to work with our order of operations. The only difference for these level 2 problems is just the complexity, a little more challenge to them, but we're going to follow the same method and steps. Okay, let's start replacing our variables. We've got a bracket, we've got p, so I'm going to put another bracket, and inside that bracket, I am going to put my value for p, which was 4. I'm subtracting q, so I'm going to put another bracket, and then I go up to my value for q, which is minus 4, and I plug that in. Now that first set of brackets is closed. And then I'm going to add 2, and I've got another bracket for where my value for p is inserted again, which was 4. And this is all under a root sign, so we need to apply that again. Now the root sign doesn't have an order, so we know that that is a square root. It has an order of 2. All right. Now let's start working through our order of operations. Our first order of operation is brackets. Now we can look at the inside brackets where we see that 4, negative 4, and 4 are all inside brackets, but there's no operations being done, so we don't have to do anything there. But we do have the first 2 terms inside a larger set of brackets. So that is the first thing we're going to look at. We're going to perform that operation. Now here's a good spot to recognize why we use the method of empty brackets and then plugging the value in. Because if we look at our second value where q was here, we have a negative inside the brackets, but we are subtracting that. So by putting the brackets in, this makes sure that we keep track of these negatives, as that is a very common mistake when we lose track of our negatives and how we work with them. So inside of our first set of brackets, which was our first step, we now have a subtraction in there, but we also have a multiplication where we have to multiply the negative out front by the negative inside the brackets. So we're going to go down our order of operations and see that multiplication comes before subtraction. So inside of our bigger brackets, we still have our 4, but now instead of minus a negative 4, I'm going to distribute or multiply the negative by the negative 4, and that gives me a positive 4. So that's our first operation inside. Now in our next term, we can continue by performing the next operation, and this one, which gives us 8. Again, that is all under a root sign, which is a square root. Now we can see under our root sign, all we have is addition. And because the root sign is over everything, we have to do that addition first, because that is like having invisible brackets underneath the root sign. We have to do everything under it first. So we now have the square root of everything under the brackets, which is 4 plus 4 plus 8, which is 16. And finally, we can take the square root of 16 to get our answer of 4. All right, let's try and work through this level 2 one, maybe a little quicker, but we're still going to follow the same method. So I'm going to rewrite my expression with the variables from my problem plugged in. So again, I'm going to use brackets to make sure that all negatives are accounted for. I've got an r, which is 2, over a p, which is 4, plus a p, which is 4, over a q, which is negative 4. Now we could simplify that first fraction using our order of operations, recognizing that we need to do division before addition. But in this case, we actually don't want to simplify because we are very close to having the same denominator. Now, when we have a negative in a fraction, in this case, our negative is on the bottom, it doesn't actually matter where in the fraction it is. That negative on the bottom is the same thing as if the negative was on top or if the negative was in front. So let's rewrite that with the negative out front, meaning our addition changes to subtraction. Now, the reason we did this is because we now have a common denominator, which we can use to subtract. 2 over 4 minus 4 over 4 is negative 2 over 4. And we can simplify that to our final answer, which is negative 1/2. Okay, that brings us to the end of this video. If you have found this useful, please feel free to like and subscribe to get more content from us. It helps us out as well. And we'll see you in the next video.